Today we'll talk about inscribed shapes. And inscribed means you're just writing something inside of a shape. And in this case, we've been focusing on circles. And so it will be objects or angles inscribed in circles. So let's first look at a circle and an inscribed angle. So right here we have our circle. And obviously it's labeled inscribed angle and intercepted arc. So let me tell you what an inscribed angle is. So go ahead and write inscribed angle. Okay, what constitutes an inscribed angle would be that the vertex of the angle is on the circle. So we're just going to check that out right now. We'll look over here. Here's that vertex and it's right on the circle, so yes. Another aspect is the sides of the angle must be chords. So for example, I know these are secants because they're passing through, but they want to know that at least it's hitting the other side. And if it only went a little bit and then stopped, then you would say that is not an inscribed angle. But if it had arrows on it, you know that it extends. So that's an inscribed angle. The intercepted arc is just the distance from this point all the way down to this point. So, and it's in degrees because it's an arc. So you have that distance. So when you have your two lines, the chords that come out, you measure from one chord to the other to get your arc. All right, so let's look at a theorem about this. So for theorem 10.8, it says measure of an inscribed angle. So we'll be able to find that angle measurement. So let's look at our picture right now. We know it's inscribed because it is on the circle, the vertex, and the lines coming out form chords. And so you have A, B, and D with your drawing. And then the C is the center, and they're just attaching those lines here and there. So it says if an angle is inscribed in a circle, which this one is, then its measure is half the measure of its intercepted arc. So if you have an angle here, it's going to be half of whatever this is. And then there's that nice formula to help you find it out. And so let's say that this is 60. Then that arc would be 120 because this is half of whatever that is. So let's look at some examples with that. So I'm going to write my formula again. So the measurement of the angle is equal to half the measurement of the arc. And I'm just going to go like that because letters change. All right, so looking at this one for A, you're either finding the arc or the angle. So if you have the angle, you're finding the arc. So I have my angle. So I know the measurement of my angle is 90 degrees. And it equals 1/2 of the measurement of the SQ arc. And so to get rid of this 1/2, I'm really just going to multiply by 2 on both sides. And so that you know that the measurement of the SQ arc is equal to 180 degrees. So that's how you found A. And for B, it's the same idea. So we're going to have B, and you go the measurement of Y, which is 115, is going to be equal to 1/2 the measurement of ZX, or XZ. So we multiply by 2 on both sides, and we get 230 here. So the measurement of the arc XZ is 230 degrees. C is a little bit different. They give us the arc measurement, but they did not give us the angle measurement. So I'm going to go the measurement of angle M is equal to 1/2 this arc here. So I have 100. So therefore I know that the measurement of M is equal to 50 degrees. Let's look at another theorem. So if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So let me go back and tell you what inscribed means. So inscribed just means that the vertices of the shape or the angle are on the circle. And we already talked about that. And so if you look at this, you have this angle here and this angle here. Well, if their chords that come out hit the same points, then their angle measurements will be the same amount of degrees. Now we're going to look at putting an actual shape into a circle, and we call those inscribed polygons. So let's look at our first one. And basically an inscribed, let me just give you an example of that. We'll draw a circle, and let's just put a triangle in there. Okay, so inscribed means all the vertices lie on the circle. So that's inscribed shape. But circumscribed means the shape on the outside. So in this case, the circle would be the circumcised shape. Circumscribed, sorry. And the triangle would be the inscribed shape. Let's look at some theorems. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. So if you look, here's your right triangle. There's your hypotenuse. It goes from end to end and goes right through the center. Conversely, if one side of an inscribed triangle is a diameter of the circle, so if you just had that diameter and you want to make a triangle out of it, then the triangle is a right triangle, and the angle opposite the diameter is the right angle right here. So if we tried to use this again, we're going to make right angles the entire time. Angle B is a right angle if and only if AC is the diameter of the circle. Theorem 10.11, a quadrilateral can be inscribed in a circle if and only if the opposite angles are supplementary. So if you look, angle D plus angle F must equal 180, and angle E plus angle G must equal 180 in order for this object to be circumcised, for this object to be inscribed inside the circle. Okay, tomorrow we will work on these concepts. Have a good night.